keyword maximum value. Yeah. Quadratics have parabolic graphs, parabola. And the maximum or the minimum value is always found at the vertex. So we need to do something with the vertex formula. Maybe we organize ourselves. Know what the parabola is yet because we don't know B. But we know A. What's the leading coefficient? Understood -1. And we know C. -75. Okay? We don't know B yet. But we know what we want the vertex to be. Once we know B, we'll take opposite of B over twice A, and that's our x value. We'll get a number there. And whatever that number is, we'll plug it back in. And we want f of -b over 2a to be exactly 25. Keyword maximum. The maximum output occurs at the vertex. To get the x value, we take opposite b over twice a. To get the output, we plug it in. So what do we want? We want to find a solution where f of opposite b over twice a is going to be exactly 25. Oh, but we already know a. Okay, so if a is -1, that'll cancel with the opposite. And double check me, but I think we're just left with b over 2. If a is -1, we're just left with positive b over 2. You see why I like the problem? You have to figure out what you want. We want the output at the vertex to be exactly 25. Now, how do we evaluate f of b over 2? How do we calculate f of b over 2? Even if it sounds silly, say what's on your mind.
Plug in b over 2 and all this possible.
Yeah. You want to calculate f of b over 2? You got to plug in b over 2 for x and plug it in here. Opposite b over 2 squared plus b times b over 2 minus 75. Of the input squared plus b times the input plus 75. And we want that to equal 25. Okay. So the last step, we need to solve this quadratic equation for b. Simplify and solve the red quadratic equation. And then we'll check our answer with the technology. Yeah. This was a super duper warm-up problem. we have two terms that are quadratic in B, and so we need to learn those terms. So maybe rename 1/2 B squared as 2/4 B squared. Oh, this isn't going to be bad. Collect our quadratic terms. -1/4 plus 2/4. We'll add 75 to both sides. Interesting. What can I clarify up to this point? Red equation, where I set the right-hand side equal to 25, becomes just B squared equals 400. What's B? Yeah, so I'm not quite sure which one it is yet. We might be both. Did I lose anyone? First possibility is that B would be positive 20. Shall we see if we get the right maximum value? Maybe some of us could graph on our calculators. I think I'm going to just use the vertex formula again. Opposite B over twice A. Opposite 20 over 2 times -1. So double check me, Jake. I think it's 10. And now I need to calculate f of 10. The opposite 100 plus 200 minus 75. 100 minus 75, that's 25. So that value of B works. Now, does the other value of B work? I don't know. Can I let B be -20? Opposite B over twice A. I get -10. So the opposite of -10 squared plus 275. Yeah, works again. Change the problem and find all values of B. Did the graph look right, Raymond? I don't know if you had a chance to do the graph.
I didn't do that.
It's okay, I just saw you calculate there. So you might leave some room there to investigate this. I like this problem also because there's this introduction of a parameter. We don't know the value of B, but it's not the variable that's in the function. So some terminology here. X is the input, it's the independent variable. F of x is the output of the function, the dependent variable. So x and f of x, that would be an input-output chart. B is a parameter that we have control of. And the question said, give me a coefficient B, so this function has the right characteristic. And as you continue in your mathematics, there'll be variables and parameters, and the parameters can take on values that the user sets. If it's a model of how to dose a person with some medication so that their temperature comes down, maybe B stands for the body weight of the person. And so calculating the dosage might depend on